Today we are looking at radicals. Now, radicals are your square roots, your cubed roots, your nth roots. So we're looking at how many factors of a certain number go into what's underneath our radical sign. So your essential question is, how do I simplify radicals? Your learning intention: I'm learning to simplify radicals. So we've got a few radical problems radical equations to solve. But let's do this reminder. If you're looking at your multiplication tables, these are what we call your perfect squares. Think about 4. 2 times 2 equals 4. So 2 is the square root of 4. 3 times 3 equals 9. So 3 is the square root of 9, and so forth. So pause the video and see if you can do the 4 questions now. Well, I do hope you tried. Remember, the opposite of square rooting is to square. So if I'm looking at this first problem, I've taken the square root of a number and I have ended up with 9. To undo that, I have to square both sides. So I will square 9 and I will square the square root of n. N is equal to 9 times 9 is 81. For the next one, once again, I'm going to square both sides. So n plus 9 will equal 1 times 1 is 1. Now it's a one-step problem. I subtract 9 from both sides and I'm done. My 9's can't zero out. N is equal to -8. When we're doing these type of problems, we have to remember to get that radical by itself before we do the math. So I need to get the square root of 5a minus 5 by itself. To do that, I will add 8 to both sides to begin with. Remember, if I have a negative number on the opposite side of the equal sign, I cannot do it because we cannot take the square root of a negative number. So these cancel out, and I've got the square root of 5a minus 5 is equal to -3 plus 5 is 5. The opposite of square rooting is squaring, so I'll square both sides. 5a minus 5 is equal to 25. Okay, I'm going to add 5 to both sides. It's gone here. 5a is equal to 30. Divide by 5. And a is equal to 6. 5 times 6 is 30. And 30 minus 5 is 25. The square root of 25 is 5. Okay, for the next one, what are we going to do? Well, we've got to get the square root of 9x by itself. So I'm going to divide by 10 on both sides. The square root of 9x is equal to 6 over 10 will reduce down to 3 over 5. Now what? Opposite of square rooting is squaring. So I square both sides. 9x is equal to 9 over 25. Now I've got a fraction I am not going to divide. I'm going to multiply by the reciprocal. So the reciprocal of 9 is 1 over 9. This cancels out. That becomes 1. 9 divided by 9 is 1. This becomes 1 over 25. So x is equal to 1 over 25. And we're done. We'll move this up and give you a minute to look at it, think about it, and write it. I hope that you were able to understand the processes, even if you struggled to get the answer. But if you understand the processes, the techniques we go through, that's about half the battle. So let's write each expression in its simplest form. So if I'm looking at this, I do what we call ladder division. It gives me an easy way to see all the factors of the number. I'm looking at that prime factorization. So if I'm looking at 48, ladder division means I kind of make it look like a ladder. I put the divisor upside down. You always start with your smallest prime number. 2 is your smallest prime number. Is 48 divisible by 2? Yes. So 48 divided by 2 gives me 24. 48 divided by 2 is 24. Is 24 divisible by 2? Yes. 24 divided by 2 gives me 12. 24 divided by 2 is 12. Is 12 divisible by 2? Yes. 12 divided by 2 is 6. Is 6 divisible by 2? Yes. 6 divided by 2 is 3. 3 is prime. 3 divided by 3 is 1. 1 and you are done. Now let's look at how many pairs I have. I've got a pair of 2's and I've got a second pair of 2's. So this is equal to 2 times 2. What's left over? Square root of 3. I'm going to pause there for a minute. Take a minute and look. If you have questions, back up and look at the video on this section again. We're not quite done. 2 times 2 is 4. 4 square root of 3 is the answer. That is the primary answer. Square roots always have two answers. We have the positive, which is your primary square root, and the negative, which is your secondary square root. So the square root of 48 is equal to positive or negative 4 square root of 3. What about the next one? What do we know about 36? Well, we know that 6 times 6 is equal to 36. So the square root of 36 will be positive or negative 6. That's one of our perfect squares. We can always do a quick check with our multiplication tables. Here's 36. I see it's 6 times 6. Until you learn those perfect squares, it might be helpful to have that multiplication table out. Okay, what about the square root of 125? Okay. Do my ladder division. Can I divide 125 by 2? No, it's not an even number. Can I divide it by 3? No. 1 plus 2 is 3. 3 plus 5 is 8. 8 is not divisible by 3. What about 5? 5 would be the next one. Yes. It ends in a 5, so it is divisible by 5. And 125 divided by 5 gives me 25. Is 25 divisible by 5? Yes. 25 divided by 5 gives me 5. 5 is prime. Divide by 5 one more time. When you get 1 at the bottom, 1 and you are done. How many pairs of 5s do we have? Just 1. So this is equal to a positive or a negative 5 square root of 5. Okay, pause the video. Can you do the ladder division on 72? Can you do that prime factorization of 72? Well, I do hope you tried. So I'm going to take 72 and I'm going to divide it by 2. It ends in a 2, so it's even number. It can be divided by 2. So 2 goes into 7 3 times, and that leaves me 12 left over. So it's 36. 36 is a perfect square. So if you recognized it as being this perfect square here, then you're ready to stop. If not, you divide by 2 again, you get 18. 18 divided by 2 gives me 9. 9 is not even, so I've got to see if it's divisible by 3. It is. Divide by 3, I get 3. 3 is prime. Divided by 3 again, and you get 1. 1 and you're done. You have a pair of 2s, and you have a pair of 3s. So this is equal to 2 times 3 square root of 2, because there's 1 2 that's not paired up. 6 square root of 2. Once again, we've got the positive or we've got the negative 6 square root of 2. So this is how you use ladder division to find your prime factorization. Because it's square root, that means we're looking for pairs or 2 of a kind. When we find a pair, we can bring 1 to the outside. If there's more than 1 pair, we multiply them together. Whatever is left over is put back underneath your radical sign. But what happens if we've got variables underneath? So if I'm looking at this, the first thing I always check is to see if my number is a perfect square. Because if it's a perfect square, then I don't have to do the factorization. So I'm going to take the square root of 441, and it is 21. So I know that 441 is 21 times 21, so I can bring that 21 out. Okay, what about x to the third? X to the third is x squared times x. So I've got a pair of x's I can bring out. And what about y squared? Well, I will be able to bring out one of the pair. So if I'm looking at this, I've got 21, because that's the square root of 441. I've got x squared, but this x does not have a pair. I've got x. I just bring 1 out, not 2. I've got y, because I've got a pair of y's. Then I've got the square root of x, which doesn't have a pair, left over. This is a positive or a negative 21xy square root of x. So if you notice, if it's an odd number, you will have one of those variables left underneath. If it is an even number, then you'll bring it to the outside. Okay, what about 648? Is that a perfect square? I don't know. So square root of 648, it is not. I've got 25.45, so I've got to do that prime factorization. I divide it by 2. In this case, because it's going to be quicker, I'm going to do it with a calculator. 648 divided by 2 gives me 324. It's even, so I can divide by 2 again. I get 162. 162 is even. Divide by 2 again. I get 81. Now, if you know your multiplication tables, you know that 81 is a perfect square. It's 9 times 9. If you don't, then you know you can divide it by 3 because 8 plus 1 is 9. So now I'm going to divide by 3. I get 27. Divided by 3, I get 9. Divided by 3, I get 3. 3 is prime. Divide by 3, 1, and you're done. So as I'm looking at this, I'm looking for my pairs. I've got a pair of 2s. I've got a pair of 3s, another pair of 3s. So this is going to be 2 times 3 times 3. Okay, what about s to the 5th power? That is s to the 4th times s. So I can bring 2 of these out, so this will be s squared. I just divide that in half. And then if I'm looking at r to the 4th, or t to the 4th, I can bring t squared out. And z to the 3rd, I can bring 1z out, and then I'll have a 1 left underneath. So this will have a 2sz underneath. So 2 times 9 is 18. S squared, t squared, z. I'm going to have to move this over. Right here, this is times. So this becomes 18 s squared, t squared, z, and then the square root of, this is s, 2sz. Oh, that was a kind of a thorny problem there. Okay, as we're looking at this next one, we need to think about it. This is the cubed root. That means I'm looking for 3 of a kind. Not 2, 3. If I'm looking at 3 of a kind, I need a negative number. So I know that negative times negative is a positive, times negative again is a negative. So my answer is going to be a negative number. If I'm looking at 750, I know it's even, so I can divide by 2. Once again, I'm going to use my calculator. I get 375. 375 is not divisible by 2. Is it divisible by 3? 3 plus 7 is 10. 10 plus 5 is 15. Yes, it's divisible by 3 because 15 is divisible by 3. Now, I've already found I've already simplified 125. That's 5 times 25, which is 5 times 5. 5 is prime, 1, and you're done. So now, as I am trying to find those 3 of a kind, this only has 1, 1. This is my 3 of a kind. So I can bring out at 5. Instead of looking for pairs, we're looking for triplets. So this is negative 5. I've still got that cubed root. I've got 2 and 3 left underneath. 2 times 3. If it's underneath, you multiply them back together. So this is negative 5, the cubed root of 6. And we're done. For the next one, we're looking for the 5th root. It is even. Once again, it is very good to use a calculator. Two 56 divided by 2, I've got 128. 128 is even. I can divide by 2 again. I get 64. 64 is even. Divided by 2, 32. 32 is even. Divide 32 by 2, I get 16. 16 is even. Divide 16 by 2, I get 8. 8 is even. Divide by 2, I get 4. Divide 4 by 2, I get 2. 2 is prime. Divide by 2, 1, and you're done. Now, how many am I looking for that have to be the same? This is my nth root, which is 5. So I need 5 of a kind. 1, 2, 3, 4, 5. I can bring one of those 5 to the outside. Is this going to be a positive or negative? No, it's an odd number, so it's got to be one or the other. So this is 2, 5th root of 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. 2, the 5th root of 8 is your answer. Okay, take a minute and look at the next 2. Once again, we're looking at those that are, this is a cubed root, this is a 4th root. We're looking for 4 of a kind, we're looking for 3 of a kind, triplets. Pause the video and see how far you can get on your own. Well, I do hope you tried. What are the factors of 80? 80 is even. 80 divided by 2 is 40. 40 is even. 40 divided by 2 is 20. Once again, an even number. Divide by 2, I get 10. Divide by 2, I get 5. 5 is prime. 5 divided by 5 is 1. 1 and you're done. I'm looking for how many? 4 of a kind. 4 of a kind and 1 can come out. A to the 6th is equal to A to the 4th, A times A squared. 1A can come out. B to the 8th is equal to B to the 4th times B to the 4th. So I will be able to bring out 2 B's. So this is going to be 2 times A times B squared. Then this will be the 4th root of 5A squared. So this is 2AB squared, 4th root of 5A squared. And for the last one, we're looking for cubed root. So 320, it's even, it divided by 2. Once again, use a calculator. It makes it quick and easy. You get 160. 160 divided by 2 is 80. 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 is prime, divided by 5 and 1, and you're done. We are looking for 3 of a kind. 1, 2, 3. So I've got a triplet there. Got another one here. One left over. U to the 6th is equal to U to the 3rd times U to the 3rd. So I'll be able to bring out 2 of these U's. V squared is not big enough to bring anything out. So now putting it all together, I've got 2 times 2, and then I'll have U squared, then the 3rd root of 5V squared. 2 times 2 is 4. 4U squared. Then the cubed root of 5V squared. Got that a little bit close, didn't I? So as you're looking at this, these that are the nth roots, you don't really have to know yet. But this is an introduction to get you ready. How do you know when you're successful? You know when you're successful if you can simplify square root of expressions. So if we're looking at this, we went through square roots. We went through cube roots, which is to the 3rd power. Anything bigger is that nth root. So I hope this is a good introduction and it's got you to thinking about how you simplify these radicals.